Hello, this is Andy from GNA Numerical, and this demonstration video shows the solutions to the calculator section of the Department for Education QTS Numeracy Test 2. If this video helps you, I'd love to hear about it. I really like hearing about your success stories. Solutions to the other practice tests can be found on our website at qtsmathtest.com. Question 1 has a scatter diagram, so let's read it. To inform the choice of reading materials, a teacher looked at the spread of reading ages in the class. The scatter graph that we can see shows the actual age and the reading age of 21 pupils in the class. And we have to find the proportion of the class who have got the same reading age and actual age, given the answer to one decimal place. Okay, so we look at what's shown here. They're actually giving us a really big clue with this big blue line here. So we've got the actual age and the reading age, and all we need to do is find the pupils that lie exactly on the diagonal line, because the line goes through 5, 5, 6, 6, 7, 7, 8, 8. So any pupil on this line is actually what we're looking for. So we count them up. We have 1, 2, 3, 4, 5, 6 of them out of 21. So we bring up the calculator. And I'm going to use the keyboard because it's quicker. So 6 divided by 21, press return, and I get 0.285. But you always look at the final statement because that tells us what format the answer is required in. So we're to give our answer as a decimal to one decimal place. So not a percentage, just leaving it as a decimal. So 0.28, so to one decimal place, that's 0.3. The next question actually follows on from the previous one, so it's the same preamble, the same actual data, and we can tell that because of these linking rings up here. So actually the first 3 questions are going to have the same data, and that's because there are 3 rings. So we don't even need to read this again, it's the same as the question 1. Now we're being asked to click on the pupil who has the greatest difference between their reading age and actual age. So last time we were interested in this blue line, and any student on that blue line had a 0 difference between their reading age and their actual age. This time we want the student who is furthest away from this line because we want the greatest difference between the reading and actual ages. So we're looking for a big distance, so it's not going to be any of these students because the dots over here representing the student are much further away from the line. So the one that's furthest away is actually this one. Certainly further away than any of these. So it has to be this student here. And we can kind of confirm that to ourselves. So let's look at his actual age. So his actual age was 6 years and 1 month. And his reading age, well, it's over 7 years for a start. So we count up 7 years and 1 month, 2 month, 3 month, 4 month, 5 months, 6 months. So that's a pretty hefty difference, and if you were to look at a few other points, it's certainly the greatest difference. So question 3, that's the final question of this set of 3 that had the same preamble and the same data. This time we're just asked for the range of reading ages for the pupils in the class. So this is another easy one. We just have to remember what the range is, and it has a definition. It's just the highest take away the smallest. So the only thing we can really get wrong in this question is reading the wrong axis. So here we're interested in just the reading ages, not anything to do with the actual ages. So just the vertical axis. So the maximum, we've actually got 2 maximums, but we just need to know what one of them is. So let's have a little look at that. So 7 years, 1, 2, 3, 4, 5, 6, 7. That was that pupil from the previous question. So 7 years and 7 months is the highest. And the lowest was, so there's 6 years and it just goes down 2 months. So that's 5 years and 10 months is the difference. So the very easy way to try this question is just to count these lines. Each one of these lines will be a month, and we can count up. So 1 month, 2 months will take us to 6 years. We know there has to be 12 months in a year, so we're on 14 months. And then we're just going to add the 7 months to get to 21 months. The other way of doing the question is, of course, to subtract 7 years and 7 months from 5 years and 10 months. And the quickest way to do that is actually to count up. So you're on 5 years and 10 months, add a year, 6 years and 10 months, add another year, 7 years and 10 months, and to take off 3 more months. So 2 years is 24 months, but we added 3 months too many, so we take them off to still get 21 months. So 2 different ways to get the answer to that one. In question 4, we have a table. So at a staff meeting, the head teacher presented this table, and it shows the number of pupils in each class in a school who are having extra music lessons. So what's the percentage of the pupils in the school having extra music lessons? Giving the answer to the nearest whole number this time. So we want the percentage of the whole school, so we're going to have to know how many pupils are in the school, and that involves adding up the number of pupils in each class. So we better get the calculator to help us do this quicker. So I'm just going to type in these numbers, so 25 plus 30 and so on. So let's do that. 25 plus 30 plus another 30 plus 28 plus 26 plus 29 plus 18 plus 24. So that gives us 210 pupils in total. So now we have to add up how many pupils in the whole school had the extra music lessons. So we can use the calculator for this if we want, but it's pretty simple to add these up. So we have 5, 10, 15, 20, 25, 37, and another 7 is 44. So all we need to do is 44 divided by the 210, and that's 0.20, but this time it wants the percentage, so we have to times our decimal by 100, and it wants it to the nearest whole number. So to the nearest whole number, 20.95 is just 21. Question 5 looks a bit scary because it's got a nasty looking formula in there, but let's break it down and see if it's actually that difficult after all. So the teacher calculates the mean point scores achieved by pupils in a test, and there's 48 pupils in the year group. The mean point score is given by the formula, so they're actually giving you the formula, and all you have to do is work out the mean point score for the year group as a whole. Give the answer to the nearest whole number. Okay, so if we're working out a mean for the year, we're going to need the total points for the whole year group and divide that by the total number of pupils in the group, which we already know is 48. So we just need the total points for the year group. So looking at this table, they've told us already the total points for levels 3 and 4 have been done for you. So we need to fill in these 2 missing boxes if we're to complete this question. So let's have a look at what they did to get this one filled in. So I'll bring the calculator up. So this first one here for level 3, it says the total points was 105. So how did they do that? Total points of 105 divided by the number of pupils, which for that level was just 5 of them. So divide by 5 equals 21. The same for here, 783 divided by 29 will give us 27. Okay, so you can see that if 105 divided by 5 is 21, then surely 21 times 5 will equal 105. And it does. So what we actually need to fill in these blanks, so for level 5 we need 8 times 33. So 264 will go here. And for the next one it will be 6 times 39, 234. So we'll add that to the figure we just worked out. So 234 plus 264 plus the other 2 that were already done for us. So that was 783 plus 105, giving a total of 1386. So that was the total points for the whole year group. and we need to divide that by the total pupils in the group, which they've told us already is 48. So we're just dividing this number by 48 to get 28.875. But that's not the final answer. We're not going to type that because the final instruction they gave us was to give our answer to the nearest whole number. So we need to type 29. Question 6. Okay, it's a wordy one. It looks horrible, but let's give it a go. Teacher is planning an outing. She has been given the costs. There are 25 pupils in the group, including pupils and teachers. The group booking for 25 tickets will cost £185, and the train tickets are going to cost £5.65 each. How much will each person have to pay to cover the costs? Okay, so there's a couple of ways of doing this. Let's bring the calculator to help us out. So we've got the theatre tickets at £185. So if we divide that by 25 for the number of people involved, that's 7.4 or £7.40 each. Okay, and we've already got the price of the train tickets per person, so we just have to add £7.40 to £5.65 to get £13.05. So the other way of doing this question would be to start with the train tickets at £5.65 and times that by the 25 people, giving us £141.25, and then you add the group ticket cost of £185, giving £326.25, so £326.25p, and you would divide that by the 25 people. So a bit long-winded, that one, but you still get the £13.05 total cost per person. So either way you still get the same answer. Question 7, a graph question again, so we like these tend to be a bit quicker to answer. So indicate all the true statements is all we have to do. So 3 separate statements, and we have to get them all correct to get the 1 point that's available for this question. So we take them one by one. The mean percentage of GCSE grades A star to C for the last 5 years of the chart was 51%. Okay, so we're interested in means again. So the last 5 years is 2011, 2010, 2009, 2008 and 2007. And we just want the average of those numbers. So let's type them in. So 47 plus 46 plus 50 plus 54 plus 58 is 255, and it's an average, so we have to divide by the number of numbers involved. So the number of years was 5 of them, so we divide by 5, and that does equal 51, so that's a true statement. So number 2, so the percentage of GCSE grades A star to C increased each year from 2004 to 2011. So let's look at that. So from 2004, yes, it goes up, it increases again, it increases. Now it didn't increase from 2007 to 2008, so that's false. Finally, the percentage of mathematics GCSE grades A star to C more than doubled between 2004 and 2011. So okay, let's look at 2004, and the average, or the percentage, was 22% of them. And so double that would be 44. So let's look at 2011, and that is way more than 44, so that is also a true statement. Question 8. So this one looks absolutely horrendous, but let's have a go at it all the same. So parents' evening starts at 16:30 on each of 2 consecutive days. The teacher has a total of 24 appointments at 10 minutes each and takes a 20-minute break on each evening. So the break time elements are something not to be forgotten about in these questions. They always put a break element in there, pretty much to try and trick you. So we have to try and remember that at some point in the question. The teacher filled all the appointment slots on the first evening and finished at 1900 hours. What was the earliest time the teacher can expect to finish on the second evening? And as usual, give the answer in 24-hour clock format. Okay, so the first thing we have to do is to work out how many appointments was the teacher able to meet on day 1. So I'd be using my mini whiteboard for this one. So okay, they started at 16:30 and finished at 1900 hours on day 1. So that's 2.5 hours minus, let's write that down, 2 hours and 30 minutes was available, minus 20 minutes because of the break time that was used. So that left only 2 hours and 10 minutes available for appointments. So 2 hours and 10 minutes in terms of just minutes is 130 minutes. So 60 minutes in 1 hour, 120 in 2 hours, plus that 10 minutes. So that's 130 minutes for the appointments. Each appointment was 10 minutes. So if that was the case, then there was no time wasted anywhere. 130 divided by 10 would be 13 appointments on day 1. Okay, so if there are 24 appointments in total, minus 13 just gives 11 appointments on day 2. So we get to finish a bit earlier, bonus. So on day 2 they're going to start at the same time, so 16:30, and there's 11 appointments, so 11 appointments times 10 minutes for each one is 110 minutes. But there's still going to be a break time in day 2 as well, so we have to add on 20 minutes for that. So that's another 130 minutes, which we already know is 2 hours and 10 minutes from the first part of the question. So we just have to add on that 2 hours and 10 minutes to our starting time of 16:30. So the quick way to add on time is to add on the hours first. So we're on 16:30, 17:30, 18:30, plus that final 10 minutes. So 18:40 is the answer. So a pretty wordy one, a pretty tough one. Definitely a question I'd be using my mini whiteboard for. Question 9. Okay, this is a particularly horrendous question, and I hope you don't get anything like this in the real test. I'm not at all happy with this question, but let's see how we go anyway. Okay, so it's a true or false, so at least if all else fails we can have a guess. There's no negative marking, so we may as well have a guess if we really have to. So indicate all the true statements. Some pupils in Class A achieved less than 12%. So here we've got the percentage marks from 3 different classes. So here we're focusing on Class A. So here, if we look at the mode, that's 72%. That means that somebody got 72%, or actually more than one person did if it's the mode, the most frequently occurring value. So let's pretend for the time being that that was the maximum value. And if it was, and we subtracted the range from it, we would be left with 12%. Okay? So it could be that somebody got more than 72%. You know, someone could have got 80%. So if they did get 80% and we minused the range of 60, we'd be left with 20%. So no matter what we do, no pupils in the class could have got less than 12%. So that's a false statement. So statement 2 says at least one pupil in Class C achieved less than 20%. So be careful here, they're trying to trick you a little bit. We're not looking at Class B, they're not going in order. They went straight to Class C, which is this one here. So at least one pupil in Class C achieved less than 20%. So okay, the first thing that catches my eye is the range for this one of 85%, which is massive because 100% is the maximum mark. And of course 0 is the lowest. So here, imagine that somebody did get 100%, a perfect score. If we subtracted the range of 85%, then the minimum would be 15%. Okay? So if the highest score was less than 100%, then the lowest score has to be lower than 15%. So in any event, any which way you look at it, the lowest score in the class has to be less than 20%. So this one is a true statement. So statement 3, all pupils in class B achieved at least 40%. So we're looking at B. So once again, it's the same logic as statement number 1. We're looking at the mode. So the mode this time was 68%. So if we subtract from that the range, we're left with 40%. So applying the same logic that we did in statement 1, the lowest mark in class B can't be less than the difference of 40%. So that one's also true. Okay, question 10, a whole lot more achievable, this question. So as part of a review program, the teacher compared the marks for 10 pupils in 2 English tests. All we have to do is click on the letters in the table for the pupils who scored at least 10 percentage points more in test 2 than they did in test 1. So they've told us the marks are out of 50, so 10% of 50 is just 5 marks. So any pupil who scores 5 or more marks higher in test 2 than test 1 is what we're interested in here. So we just have to look at them one by one. So here that's only a 2-mark increase, that's 4. That one went down. 17 to 22, that is 5 marks, so we're interested in him. That's only 4. 20 to 29, that's a big increase, that's good. That one only went up by 2, so that's not enough. This one goes up by 5. This one didn't go up at all, and this one goes up by 10. So there's actually 4 students we're interested in, D, F, H, and J. Question 11, back to our firm favourite, the box and whisker diagram, and it's even a true or false question, so these are usually pretty easy to do. So what we're looking at here, so statement 1, the range of percentage marks was greatest in class A. Is that true or false? So here we can easily see in about 1 second that has to be a true statement, because they have the same maximum, but the minimum for class A is just a bit bigger, so the overall size of it, or the range, is larger in class A. Statement 2, the median percentage mark in class A was 15 percentage points less than the median in class B. Well, let's have a look at that. So the median for class A was 45 with this white line, and for B it was only up to 50, so that's only a difference of 5, so that's a false statement. Finally, the interquartile range was the same in both classes. So this is a textbook type question. You just have to know what is this thing called interquartile range. So the definition of it is it's the difference between the upper quartile and the lower quartile, or in simpler terms it's just the size of the box. So here's the upper quartile in class B, there's the lower quartile, so the difference is 10, and the difference is 10 for class A as well, so that is a true statement. That was so quick and easy to do compared to some of the other questions we've been doing. So you tend to find that the graph questions are very, very much simpler than the other types of questions. Question 12, another wordy one, so let's have a read. Teacher plans a school trip to Brussels involving a ferry. The teacher wants to be in Ostend, the location, no later than 1600 hours. She expects the coach to travel from Brussels to Ostend, which is a distance of 120 kilometers at an average speed of 50 miles per hour. Using the approximation 5 miles is 8 kilometers, what is the latest time that the coach should leave Brussels? Give your answer using the 24-hour clock. Okay, that is a pretty tough question, so let's break it down into smaller pieces. So what do they tell us first? So they tell us they have to be there by 1800 hours. They've got a distance of 120 kilometers to travel, and they expect to go at 50 miles per hour. So straight away that isn't really consistent. We've got miles per hour and kilometers to travel, so there's an inconsistency there. We're going to have to convert one of these so that we're dealing like with like, but we'll deal with that in a minute. We are also given a conversion rule, which is always a good help. They're telling us 5 miles equals 8 kilometers. Okay, so the first thing we have to do is to work out how many miles is 120 kilometers, because once we do that, then we've got the speed and the distance in compatible units. So our target is 120 kilometers, and we know that 8 kilometers is 5 miles. So one way of doing this is to say, well, what do I multiply 8 by to get up to 120? And the way to work that one out is to bring the calculator out and do 120 divided by 8, which is 15. So that's the hardest part of the question done, really. So we have to match what we've done on this side of the equation to this side. So we multiply by 15 on this side. 5 times 15 is 75 miles. So now we know that 75 miles is 120 kilometers. So now we can start to really break into this question. So you may remember this equation from school, maybe not, but don't worry. So speed equals distance divided by time. If you're not a fan of equations, let me write it a slightly different way. You might like it better. So we've got speed, distance again, and time. And I'll put all of that in a triangle. So what we want to know is the time. So if we want to know the time, this little rule of thumb says, okay, the thing that you're interested in working out, cover it up with your finger. I'm going to score it out. So we want to know the time. So the formula becomes the distance divided by the speed. So let's fill in those details. So the distance we worked out was 75 miles divided by the speed, which was 50 miles an hour. 75 divided by 50, 1.5. So that's 1.5 hours. Now we know that it took them 1.5 hours to cover the distance. So now that we know that, we can have another look at the question. If they're going to arrive no later than 6 o'clock or 1800 hours, they have to leave an hour and a half earlier than that, which is 1630 hours. So that was the answer to the question, a pretty nasty one. I'd certainly use my mini whiteboard for this question, or I might even be tempted to flag the question and move on and hopefully come back if I had time. Before I move on to the next question, I want to say something more about this triangle I drew out. So distance, speed, time. So if I drew another one, if we were interested in working out the distance and we had the other two quantities, you cover up the d, the formula becomes speed times time. If I draw another one out, imagine we were interested in knowing what the speed was. Well, speed, cross out the speed, distance divided by time. You're always going to be given 2 out of the 3 quantities to work with. Okay, so this triangle rule here, this avoids rearranging equations, which a lot of people are not very comfortable with. And for this exam, we want to do things quickly, so this often helps in the speed element of it. Okay, next question. Question 13. So we've got a pie chart, which is usually a really good question, really quick to get the answers to these ones. So let's have a look at it. So the head of careers supplied the following chart to the destination, or showing the destination of year 13 leavers. We just have to indicate all the true statements. So okay, 3/7 went on to higher education. Okay, so what we have to do first is that we've been given the numbers in each destination, so we have to add them up first. So let's bring the calculator up, and I'll use the keyboard because once again it's the quickest way. So 82 plus 14 plus 38 plus 48, press return, is 182 pupils. Okay, so now that we know that, the rest of this question will be very simple. So 3/7 went on to higher education. Is that true or false? So okay, let's type 3/7 into the calculator. 3 divided by 7, and we'll times that by the total number of pupils, which we just counted to be 182, times 182, and that equals 78. So is that true or false? Well, that's definitely false, because on the chart it actually says 82, so that's definitely false. Don't worry about all these zeros, I'm not sure why that happened. So the next one, 1 in 13 took a gap year. So once again we type that into the calculator. 1 divided by 13 times by 182 students equals 14. So let's have a look. So gap year is this kind of blue purple color, and yes, that is true because it says 14 on the pie chart, so that is a true statement. Finally, 2/7 went on to further education. So you get the idea by now. So on the calculator, 2 divided by 7 times by 182 students equals 52. So further education is the orange color, and it's nowhere near 52, it's only 38, so that's definitely false as well. Nice and easy question, this one. Question 14, we've got a bar chart. So the question says we have a science class of 30 pupils. We're given 2 tests. Test 1 at the start of term and test 2 at the end. As part of a review of the pupils' progress, the teacher prepared the bar chart below showing achievement in the 2 tests. So we've only got to indicate the true statements. So statement 1, the number of pupils achieving 81 or more marks increased by 50% from test 1 to test 2. So 81 plus marks, well, there's a category for that on the chart, from test 1 to test 2. So test 1 is the blue color and it has 2 pupils getting that. To work out the percentage increase, we can apply a formula. So the formula, if you're interested, says, well, it's the number afterwards, the event. So 6, take away the original amount is 2, and then you divide by the original amount, if you're still with me, and then times by 100 to get the percent. So we would do 6 minus 2 to get 4, divide by 2 to get 2, and times by 100 to get 200%. So it's actually a 200% increase, which is not true because here they were just interested in it being a 50% increase. We could even tell, without even working out all that, we could tell that this was a false statement, because if it doubled, it would be a 100% rise, and a doubling would only still get to 4, so it's even more than that. Anyway, statement 2, more than 80% of pupils achieve more than 40 marks in test 2. So here we're interested in these categories, 41 to 60, 61 to 80, and 81 plus, just for test 2, which is the orange color. So here we've got 13 pupils, plus 6 and plus another 6. So that's 25 pupils, and it's 25 out of the total of 30. So we'll divide by 30 and times by 100, which tells us that 83.3% of the pupils achieved more than 40 marks in test 2, which this is a true statement because that is more than 80%, so that's true. Finally, 1/3 of pupils achieved fewer than 41 marks in test 1. Let's have a look at that. So test 1 is the purple color. Fewer than 41 marks is these 2 categories, 21 to 40 and 0 to 20. So we've got 7 pupils here. Let me clear this. We've got 7 here and 3 here. Well, 7 and 3 is 10, and we already know it's out of 30, so it's 10 out of 30. We can simplify that by dividing the top and the bottom of the fraction by 10 to get exactly 1/3. So that is also a true statement. Question 15. This one looks really bad. It's a lot of words and there's even a nasty equation in here. Okay, so in order to predict pupil performance in a GCSE subject, the teacher produced the following table. The table shows marks achieved by 3 pupils in coursework and an exam. Using the previous year's results, the teacher set a minimum final percentage mark of 55 for a C grade. Then we see some formula here. Okay, our instruction is to click on the letter of the pupil, so X, Y or Z Well, okay, we've got a 1 in 3 chance of getting this right, if nothing else. Who is predicted to achieve this grade C? Okay, well that's quite an inventive question. So let's think about this then. So we'll probably need the calculator, so let's bring it out ready. So coursework, and the mark is out of 60. And if we look at this formula here, it says coursework percentage mark. So the first thing we need to do, if we're going to just look at pupil X, is to convert this score of 22 out of 60 to a percent. So I think you know how to do that by now. It's 22 divided by 60 gives us the proportion as a decimal, and then we multiply the decimal by 100 to get the percent. So that's 36.6666. So we'll remember that for now. The practice exam, so the second part of the equation says, okay, you're going to add that 36.6% to 3 times the practice exam percentage mark. So here we've got a percentage mark already, so no conversion to do, it's just plus 3 times 45. So let me cancel this now. We do 3 times 45, it's 135, and we add on that 36.6666 that we just worked out a minute ago. We get 171.6, and then the formula says to divide all of that by 4. So we'll do that now. Divide by 4, and we get 42.9. Okay, so that one is nowhere near a C grade because the minimum mark to get a C was 55. So he's below that, so he's not the pupil we're interested in. But we probably could have told that already, because 22 out of 60 and 45 out of 100, that's pretty low scores there, so we probably shouldn't have started with that pupil, but there you go. So we do the same process for the next pupil and see if he's our one. So 21 out of 60 is 0.35, so times him by 100 I know is going to be 35, but let's just prove that. Times 100, 35, and we're going to add that to 3 times 60, so that's adding 180, so we'll add that. 215, divide all of that by 4, and we get 53.75, which is closer, but it's not quite over the threshold that the teacher set, so he's not our pupil either. So one of these has to be correct, and if it's not X and it's not Y, then it has to be Z. But you're probably interested to see why Z is the correct answer. So let's go through the process again and show why that is the case. So once again, coursework mark 30 out of 60. Well, that's just a half, isn't it? So that's 50%. And we add to that 3 lots of 58. So 3 times 58, 174 plus 50. Once again, divide all of that by 4. And we get 56, which is just over the threshold for getting a C grade. So after all of that palaver, Z was the correct answer. How are you doing? You still strong? Well, we've made it to the final question now. So question 16. The teacher looked at past achievements in Key Stage 2 assessment for the period 2009 to 11 in order to predict GCSE achievements for some pupils. Indicate all the true statements. So once again, 3 questions to answer. Statement 1. In 2009, the teacher assessment result for each subject was above the corresponding test result. So okay, only focusing on 2009, so we ignore the other ones for now. So let's have a look. So the teacher assessment here was higher than for the test. And for maths, it also was. And for science it was not, so that's not true. So statement 2. In 2010, the teacher assessment result was closer to the test result in English than it was in science. Okay, so English and science this time, 2010. So here's English. The difference between the scores here is just 2 marks. Not maths, they weren't interested in that, so science, the difference here was 3 marks. So this is a true statement because there's only a 2-mark difference here and a 3-mark difference here. So the result was closer in English than science, so true. Finally, taking account both teacher assessments and the test assessments, the The trend in both English and maths indicates improved performance. Okay, so English and maths only. So we're looking at a trend. So that's a trend over the whole time period. So let's have a look. So 68, it goes up to 72, it goes up again, so that one's fine. 60 up to 70, up to 75, so English is fine. Let's try maths. 66 goes up to 72, up to 76, that one works as well. 56 to 66 to 74, so that's continuously increasing in all of the different categories that the question talked about, so that's also true. Out of interest, let's look at science. So 76 to 77 to 81, so that one's okay. But for this one it's not. It goes 82 down to 74, so that one would break the rule. But the question didn't talk about science, but I just looked at it anyway. So test over. Well done if you made it through all of that. So I hope you found the video useful preparation for your exam. And please don't worry too much about understanding every little detail of every single question. You don't need 100%. There's no special prizes for that. You just have to get the pass mark. And I wish you all the very best of luck with your QTS tests. Bye for now.